Alright, this is Algebra 2, 6-2, multiplying, dividing radical expressions. So the first rule that they give us is multiplying radicals with the same index. So if I have something like 6 to the third and I multiply it times something else like 3 to the third. Since the indices are the same, there's a 3 here, there's a 3 here, then I can multiply the inside. These two guys can multiply. So I have one radical, and I can multiply the 6 times the 3. And I could put it under the index of 3, and this would give me 18 inside, and to be raised to the third power. That's what that property says. So, for over here they ask, for A, can I use that property? And I have 7 fourth root times 7 fifth root, and this would be a no. You can't combine these and multiply these because this one has an index of 5, this one has an index of 4. They're not the same, therefore you can't do it. Now for B, that's a little different. They both have an index of 5, so this is -5 square or fifth root, and this is -2 fifth root. They do have the same index. They both have an index of 5, so I can multiply the numbers and underneath the radical. You can have -5 times -10, 2 rather. No, that's fifth rooted. So it would be the fifth root of +10. And this would be my answer. Okay, so if they are of the same index, then I can multiply the numbers under the radical sign, or I can multiply the radicans. Okay. So simplifying or reducing radicals. So once upon a time, when you guys were simplifying radicals, they use 24 as an example. You could try to find perfect roots. So this would be 4 times 6, as 4 times 6 is 24, right? And then we can separate those out. Square root of 4 times the square root of 6. And the square root of 4 is 2. Times the square root of 6. And we would say that in this simplest form or reduced form, it would be 2 square root of 6. Well, we can do the same thing with perfect cubes, perfect forts, perfect fifths. They all apply. So with an example of that, we have for number 2, 128 x to the 7. That whole thing is being cube rooted. So now I have to find a perfect cube of 128. And what I can do is I can separate these out. Let's focus on the 128 a bit. So this is a cube root, right? So I have to think of three numbers that I can multiply to get to 120, that I can factor out from 128. So if I try 2, right, 2 times 2 times 2, that gives me 8. And can I divide 128 divided by 8? Yes, I get 16. So that's a contender. Then I can try 3 times 3 times 3. That gives me 3 times 3, 27. Can I divide 128 by 27? Nope, I cannot. Then I have 4 times 4 times 4. And that gives me 64. Can I divide 128 divided by 64? And I can. So this is really looking like a contender. The 5 is not going to work, so let me try 6. 5 times 5 times 5 is 125, and I can't divide that. And then 6 times 6 times 6 is 216, and that's more than 128. So the biggest number that I can factor out here is 64. So that's going to be the number that I'm going to use. So it's going to be 64 times 2. Okay? So that's the number part. And I focus on this guy. Remember from the last time I usually divide 7 divided by, or the number divided by 3, but that will give me a fraction. So I'm going to split this up such that I can easily divide that by 3. So the way that I can split it up is I can have x to the 6 times x to the 1, or x. And the reason why I'm doing that is because x to the 6 times x to the 1 is the same thing as saying x to the 6 plus 1 from our exponent rules, and that's x to the 7. So these guys are equivalent expressions. Well, I can do the cube root of x to the 6. I'll just divide it, and that's going to be x squared. And I leave the x1 over here. So then that's times x to the 6 times x. Now I'm going to, and all of this is cube rooted. Now I'm going to combine the 64 with the x to the 6, and I'm going to cube root that, and I'm going to multiply 2x over here and cube root that. These guys are the same. Well, the cube root of 64, we already know that it's 4 times 4 times 4, so that's going to be 4. 6 divided by 3 is 2, so that's going to be x squared times the cube root times the cube root of 2x. That would be my simplified form. Again, I sort of did sort of a guess and check to get the 4 times 4 times 4. Most of these are not going to be higher than, like 2 cubed, 3 cubed, 4 cubed. Rarely will you see a 5 cubed. In these problems. Alright, so Simplifying products. So if you look on the example that they give, we're multiplying to square roots of stuff underneath the radical symbol. We multiply these through, and then we try to simplify them. And as you try to simplify, you can then also reduce or to its simplest form after you multiply through. So let's try one. So the square root of 45 x to the 5 y to the 3 times square root of 35 x y to the 4th. Okay. So we're going to multiply 45 x to the 5 y to the 3 times 35 x y to the 4th, and all that square rooted. So numbers to numbers, same variables to same variables, so 45 times 35 x to the 5th times x to the 1 y to the 3rd times y to the 4th. 45 times 35, that's going to be 1575, and then x to the 5th times x to the 1, right? There's a 1 here. I add their exponents, so that's going to be x to the 6th. Y to the 3rd times y to the 4th. Again, I add their exponents, so that's y to the 7th, and all that's being square rooted. And in this case, I got to think of a number that I can divide this out. So I look at the 5, right? And when I look at the 5, that tells me that I could probably divide it by either a 5 squared, a 15 squared, or a 25 squared, or a 35 squared, something like that, with a 5 at the end. So I try 25, and I get 63, so I can divide it by 25. So if I look at 15 squared, which is the next one up, that's 225. Can I divide 1575 by 225? Yes, I can. Hallelujah. And then 25 squared is 625. So can I divide 1575 by 625? And I cannot. So that's not going to work. And then 35 squared, that's 1225. And I cannot. So it looks like the contender is going to be 15 squared. So 15 squared is 225. So I'm going to separate the 1575 into 225 times 7. Okay, 225 times 7. So 225 times 7. Here I can divide it's 6 divided by 2 and get 3, so I can leave this alone. Here, since this is 7 and 2 divided by 7 is a fraction, I'm going to split this up into y times 6 times y, or y to the 1st. All of this is square rooted. Then I'm going to separate that, and this is going to be 225 times x to the 6 times y to the 6 square root times 7 y square root. 225, the square root of 225 is 15. 2 divided 6 divided by 2 is 3. Y divided by 6 divided by 2 is 3, so it's y to the 3. Absolute value, because they're odd, times square root of 7y. That would be my answer. That would be simplified. Combining radical expressions. So I can divide radicals as well, or the radicands within them. So let's say I had 10 squared divided by square rooted divided by 5 square rooted. Then I can actually do 10 divided by 5 and square root the whole thing. Okay? Which gives me 2 square root of 2. Okay? I can also do that with radicals as well. So an example of that, we have 2. Here's A, where they divide 18 divided by 2, which is 9. X to the 5th divided by x to the 3rd. We subtract the exponent, so it's 5 minus 2, which is 9x squared. We square root the 9. That's the 3. And we square root the x squared, which is x. Here, same thing. 162 divided by 3 is 54. 5 divided by 2 is 3. So 54 can be broken up into 27 times 2, which is a factor of 3 times 3 times 3. So the square root of that is 3. Cube root, rather, of that is 3. Cube root of y to the 3rd is y. We would factor out or pull out the cube root of 2 and be 3 cube root of 2. So what is this guy in its simplest form? 50 x to the 6 over 2x to the 4 square rooted. So I can do 50 x to the 6 over 2x to the 4 square root. 50 divided by 2 is 25. And then x to the 6 minus x to the 4 is x squared, square root. 25 square rooted is 5. And then x square root squared is x. 5x. So actually I like 4b, and the question that they asked for 4b is, can you simplify the expression in 4a by simplifying them first before you divide it out? And the answer is yes, absolutely. So what does that mean? Well, instead of me doing the division and then square rooting, I can actually simplify it. So if I was to do square root of 18 x to the 5th, I can actually pull out a 9. So I could say 9 x to the 4th square root times 9 times 2 is 18, and then x, and that would give me 3x squared. times 2x. That would be my numerator. And then for my denominator, I have 2x squared cubed square root. So I can pull out an x squared and say this is x squared times 2x, which would give me, and this would be in the denominator, x times 2x square root. So having that, 3x squared square root of 2x over x square root of 2x. The 2x's square root cancels out. Here's a 1 here. 2 minus 1 is 1. So I get 3x to the 1, which equals 3x, which is the same answer that we got for A. So I can do that, or I could just divide it through and then square root, which is a lot easier. Rationalizing the denominator. So this one's actually a little tricky. We can multiply the fraction such that there is no square roots or cube roots or any type of radical symbols in the denominator. So the example they give over here is 1 square root of 2, and we don't really like square roots in the denominator anyway. We multiply it by square root 2 over square root 2, which gives me square root 2 over these two guys cancel, right? So this is 2 squared square root. The square root and the square cancels, and that leaves me square root 2 over 2. This guy and this guy cancels. This would be considered sort of simplified because the denominator doesn't have a radical symbol. But it's a little bit different than just multiplying it by itself. We have to multiply it either by a perfect square, by a perfect cube, by a perfect fourth. So I'm going to go through the first example to sort of make you understand where this is sort of coming from. So 5x squared cube root over 12x y squared z to the first cube root. Okay. So we want these things in terms of perfect squares, right? I'm going to break up the 12 into a factor of great. Into a factor of 4 times 3. These aren't perfect cubes yet. We're going to turn them into perfect cubes by multiplying it by this other number in the denominator. This guy is a perfect square, right? 4 squared is a perfect square. And in this case, we're going to write 4 squared as 2 to the second power. This guy we're going to keep, say, like 3 to the first power. Okay? So yeah, 3 to the first power times 2 to the second power. And the reason why I'm doing that is because I'm looking for a perfect cube. And this 2 tells me that I need one more 2 in order to turn this into 2 cubed, because 2 cubed, cube root, is 2, right? 3 cubed, cube root, is 3. So this number here, by doing it this way, tells me how much more I have to multiply to get to 2 to the third power. So if I have 2 to the second power, then I have to multiply it by 2 to the first power. If I have 3 to the second, or actually it was 3 to the first, right? 3 to the first power, I have to multiply it by 3 to the second power to get 2 to the third, or in order to get 3 to the third. That's the point. So I can't just, I have to get it sort of in a perfect square form for this to happen. I look here, I have y to the second. But in order for me to get it to a perfect cube, I have to have another y to the 1, right? That's going to give me y to the 3, and I can cube root it, and that'll give me y. Here I have z to the first, so I got to multiply it by z to the second in order for me to have z to the third, so that I can cube root it to make it a perfect cube to get z. And again, eliminating all the radicals. So those are the numbers that I'm going to multiply this by. I'm going to multiply this by 2 to the first power, 3 to the second power, y to the first power, and z to the second power. This is going to be cube root. What I do to the bottom, I must do to the top. So this is also being multiplied by those same numbers. 2, 3 squared, y, z, and this is cube rooted. So this is where this comes from. Alright, that gives us this numbers right here, 90 x squared y z squared to the cube root alpha. So the purpose of that was to multiply and to get perfect squares, right? So this is now a 2 times a 3 cube root because they cubed out yz. And 2 times 3 is 6. So it's going to give me 6 yz. And this would be considered simplified because I took out the denominator. This guy, I can't really pull out anything to simplify it any further. These guys don't have any cubes, so I can't do anything with those guys, so this is done. Okay, so let's do another one. This is 7x cube root over 5y squared. Okay, this is also cube rooted. So remember, this is basically 5 to the 1. So I'm going to have to multiply it times 5 squared in order for me to get 5 cubed cube root. So I'm going to multiply times 5 squared. There's a y to the second, so I'm going to multiply that times y to the 1 so that I can have y cubed cube root, so that gives me my 5. That gives me my y. So I'm going to turn this down here into 5y. So this is times the cube root of 5 squared times y, or y to the first. What I do to the bottom, gotta do to the top. 5 squared y. So that gives me 175 times x times y, and this is being cube rooted, over 5 to the third y to the third, cube rooted, which gives me 175 x y cube root over 5 y. And I'm done. Alright, so that is that section. I hope you have a great rest of your day.